Today we will be learning how to solve a given system of a non-homogeneous equation which is going to have a unique solution in this case. As in the previous lecture I have explained you there are three types of solution which can exist to three cases actually which can exist to given system of non-homogeneous linear equation. The first one was a solution does not exist. And now the second one which we are going to do today, that is the solution XX, that is a given system of equations are consistent and there is a unique solution. That means this time the rank of given rank of a coefficient matrix A and the rank of augmented matrix are going to be same, with the condition that that is equal to the rank is equal to the number of variables. Let us have one example and we will be doing solving that. Here we have been given the first equation as 2x minus y plus 3z that is equal to 8 and minus x plus 2y plus z equals to 4 and 3x plus y minus 4z is equal to 0. We can write z as this or at this one. Here I have converted that because it was looking like 3, that's why I have changed that. You can take that as like this. Now when we go to the solution, first thing is we will write augmented matrix. Augmented matrix of the given system of equation. We will write the coefficient of x first, that is 2, minus 1, 3. Then second, that is y coefficient minus 1, 2 and 1. Z coefficients are 3, 1 and minus 4. Then we will draw a straight line. We will write the right side numbers. Those are 8, 4 and 0. Now this is the augmented matrix. We have to find out the rank of this matrix. Now to find out the rank, we need to make this element and this element as 0, because we need to convert that into the echelon form. That means below the diagonal we have to make the element as 0. Now to do that, here it is 2 and this one is minus 1. What we will be doing, we will be taking 2 times of r2, it will become minus 2. We will add with this corresponding element, that is 2. So we will add r1 to that. Now for the next, that is here we are having 3, that is r3, and if we want to have a LCM of this number, this is 3 and this is 2, then we can have a common number, that is 6. So we will be multiplying row number 3 by 2 to make it 6, and then we will multiplying r1 by 3 to make it 6. If we multiply this by 3, it will become 6. So we will multiply this by 3, both will become 6, and if we subtract, we will get 0 for this place. Now we are doing operation on row number 2 and row number 3. So we will be copy pasting the row number 1 because we are not changing that. So we have here 2, minus 1, 3, and the right side, that is 8. Now we will be doing the rough work for that. Now the first operation, that is 2 times of r2 plus r1. We will be multiplying r2 by 2, that is 2r2 If we multiply this row R2 by 2, it will become minus 2, 2 to the 4, 1 to the 2, 4 to the 8. Now we will write R1 elements. R1 elements are 2, minus 1, 3 and 8. Now we will subtract. This will, when we subtract, sign changes. Now minus 2, sorry, we are adding, so sign will not change. Now minus 2 and plus 2 will become 0. 4 minus 1 is 3 and 2 plus 3 is 5 and 8 plus 8 is 16. So we will write that it is a 0, 3, 5 and 16. Now we will be doing the second operation. For that, the operation is 2 times of R3 minus 3 times of R1. 2 times of R3, we will be taking the R3 elements, 2 times of R3, that is, this is R3. So we will be multiplying that by 2, it will become 6, 2, minus 8 and 0. And then we'll be having 3 times of R1. R1 we have this one, because we have not done any changes in that, so this one and the previous matrix R1 is same. So we'll be multiplying this by 3, it will become 6. Then 3 into minus 1 is minus 3, 3 3s are 9 and 3 8s are 24. This time we are doing the subtraction, so sign will change. 6 minus 6 is 0, 2 plus 3 is 5, minus 8 minus 9. It is 9 plus 9, both will be added. 9 plus 8 is going to be 17, and this is going to be with the minus sign, and this will be minus 24. So we will be doing here, this is 0, so it is going to be 0, 5, minus 17 and minus 24. We will be once again checking that. Okay. Now, if we look at this diagonal element, below the diagonal, only this element is left, that is 5. We have to make this as 0. This is 5, this is 3. LCM is going to be 15. So, the operation to make this element as 0, we will be taking R3 will be multiplied by 3, then minus, we are taking this corresponding element 3, that is R2, will multiply that by 5, so both will become 15 and hence we will make it as 0. Now, we are changing the row number 3. So 1 and 2 will remain same this time. So it is going to be 2 minus 1, 3, 8 and 0, 3, 5 and 16. Now we will be doing the operation here. That is R3, 3R3 minus 5R2. We will write R3 elements, we'll multiply by 3. Now if we multiply this row by 3, it becomes 0, 5 3s are 15 and 17 5s are, sorry, 17 3s are, 7 3s are 21 and 3 1s are 3 plus 2 5, 51 with the minus sign. And then we will multiply 24 by 3, it will be 4 3s are 12 and 3 2s are 6 plus 1 7 with the minus sign. 5 times of R2, now we will be multiplying, this is R2, we will be multiplying this by 5, 5 zeros are 0, 3 5s are 15, 5 5s are 25 and 16 5s 18. We have to subtract, sign will change. Now 0 minus 0 is 0, 15 minus 15 is 0. Both are of same sign. Now they will be added together. 5 plus 1 is 6, 2 plus 5 is 7, and here again they will be added 2 because they are of same sign. 8 plus 7, 15 with the minus sign. This one will be also with the minus sign. It is going to be 0, 0, minus 76, minus 152. Now we got this in the echelon form. Now if you look at this one, the A matrix, that is this part, the rank of this matrix is 3 because the first row is non-zero, second row is non-zero, third row is also non-zero. So the rank of A is equal to 3. And if you look at the augmented matrix, that is a full matrix, the first row, that is from here to here, non-zero, second is non-zero, and third one is also non-zero. That is same as rank of that is 3 is the rank of augmented matrix. That is a rank of the augmented matrix AB. Now the rank of both the matrices are same, that is A and its augmented corresponding augmented matrix. That clearly shows that the given system of equations are consistent. Now when it comes to consistent, there are two cases, maybe unique solution, maybe infinite solution. When the rank of A is equal to the number of variables, then we say that there is a unique solution. Since rank of A is equal to 3 is equal to number of variables. Now if we look at the question, we had 3 variables, one is x, other is y, third one is z. So the rank is 3, number of variables are also 3, therefore there will be unique solution. Is it clear? The first point you need to look at, the rank need to be same for A and augmented matrix. If it is same, that means solution exists, it is system of equations are consistent. Now when it comes to consistent, there are two cases, one is a unique solution, other is infinite solution. If the rank of A is equal to the number of variables, then in this case first criteria is this, first point this, that need to be same, second is this, then rank of A is equal to the number of variables. If these two criteria are satisfied, that means there will be unique solution. Remember that the first need the rank of A and augmented matrix need to be same. Second is the rank of A or rank of augmented matrix, since both are the same, that should be equal to the number of variable given in the question, that is equations. Then if these two conditions are satisfied, then there will be unique solution. That means there will be one common solution to that system of equation. Now we will be trying to find out what is that solution. Now we will convert this equation into the given matrix in the equation format. In equation form, from augmented matrix, now what is the first row? 2, minus 1, 3 and 8. So we will write 2, minus 1, 3 and 8. This is the right side. First variable is x, second is y, third is z. Here negative sign is not given, that means it is a plus sign. Now go to the second equation, 3, 5 and 16. So we will write 3 is the y variable. So we will write here 3, 5 and the right side is 16. This is with the plus sign, y variable, then we'll put plus sign here, this is z. If it is in a minus, then it will remain minus. If nothing is written, that means it is a plus sign. Now the third equation from here, that is this one, is going to be minus 76 and 152 with the minus sign. Minus 76z equals to minus 152. Now if you look at this, see, always remember here the x coefficients are 0, so we have not written. Here the y coefficient in the third equation is 0, so I have not written that. So the coefficients which are 0, they will not be written in the final equation. We will name this as 1, we will name this as a 2, this as a 3. Now from the third equation, from 3, if we simplify minus 76z is equal to minus 152, that means z is equal to minus 152 divided by 76 with the minus sign. This answer comes as 2. Now substituting value of z in 2. Now if we look at the equation here at 2, that is this equation, so we have 3 times of y plus 5 times of z. Z is we got as 2, that is equal to 16. We will simplify this one. This is a 3y is equal to 16 minus 10. This product will become 10, will go to the right side, will become minus 10. So 3y is equal to 6, y is equal to 2. So we got the second answer. This is the first one, this is the second one. We got the answer for z, we got the answer for y. Now substituting value of y and z in equation number 1. Now what is equation number 1? Let us see that first. It is this one is equation number 1, that is 2x minus y plus 3z is equal to 8. It is 2x. Then the next one is minus y. Y is 2. We will put that. Then plus 3z, that is 3 into value of z we have calculated as 2 is equal to 8. So 2x minus 2 plus 6 is equal to 8. 2x plus 4 is equal to 8. So here 2x is equal to 8 minus 4. This 4 will go to the right side, will become minus 4. So we got this as 4. 2x is 4, so x is equal to 2. Therefore the solution of given system of equation x is equal to 2, we got y, and we have z also, z is also 2, and value of y is also what we have got. See here, we got z here, that is 2, we got y, that is 2, and z is also 2. So x is 2, y is 2, and z is also 2. This is our answer. So the procedure again, I will repeat it for your understanding. Whenever you have been given a system of equation, I will start from here, starting point, this is the question is given to solve the given system of equation. As we look at the right side, they are non-zero. There is at least one non-zero element. That shows that it is a case of non-homogeneous equation. The right side, if you look at this, it is here 8, and this next one here, this is 8, this is 4, and this is 0. It clearly indicates that this is a system of non-homogeneous equation. In the system of non-homogeneous equation, there are 3 cases. One, the system of solution does not exist. That means system of equations are inconsistent. The second comes as system of equations are consistent. In the consistent case, there are 2 cases. The one is solution exists and it is unique, and the next one is the solution exists and infinite solutions are there. Now first thing is we have to write that given system of equation in augmented matrix form, convert that in the echelon form, and then find out what is the rank of A and what is the rank of augmented matrix. Now here I have converted this into the echelon form. That means you have to convert that into the upper triangular matrix form format for the A part, that is coefficient matrix, and we got these 3 0. Now from this we can predict the rank of this box, that is matrix coefficient matrix, that is A. Here the first row is non-zero, we have 2, -1 and 3. Second row is 0, 3 and 5. That is also not 0. Third row is 0, 0 and -76. That is also not equal to 0. That clearly says that all the 3 rows are non-zero rows, hence rank of the A is going to be 3. Is it clear? Now if we take all together, that means the first row has a 2, -1, 3 and 8. That is non-zero. 0, 3, 5 and 16. That is also not 0. The third row is 0, 0, 76 and -152. That is also not 0. That means the rank of augmented matrix is also 3. Now when it comes to 0 row, as I have already also told you that a row is said to be 0 row if all the elements of that row are 0. A row is said to be a 0 row if all the elements of that row are 0. If any one of them is non-zero, then we say that as that row is non-zero row. So here all the 3 rows for the augmented matrix are also non-zero. That means rank of A and augmented matrix both are same. When rank of both are same, then the second point which we have to check that the rank of A is equal to the number of variable or not. If it is equal to the number of variable, that means there will be unique solution. If that is not equal to the number of variables, then there will be infinite solution. That part we will be doing in the next class. Now here the rank of A is equal to the number of variable, that means there will be unique solution. Unique solution means there will be one common solution. Now we will be converting the given augmented from the given augmented matrix, actually what we have got in the last step, that is this one. From this we will convert that into the equation format. So we will be writing the first equation. This is the x coefficient, this is y coefficient, this is z coefficient, this is right side. So it is going to be 2x minus y plus 3z is equal to 8. Here x part is 0, so we will not write that. So 3y plus 5z is equal to 16. And here x and y both are 0, so we will be having z minus 76, z is equal to minus 152. Now we have got that as here. Now from the third equation we will be getting the value of z, that is minus 76, z is equal to minus 152. From that we will be having z is equal to 2. Now after that, once we have got the value of z, we will be substituting that into the previous, that is equation number 2. We call this procedure as a back substitution, because from the last we will be getting z and then we will be substituting whatever the value we have got in the earlier equation to get the value of another variable. So here we are substituting value of z, we got the value of y as 2. Now we have the value of y and z, we will substitute the value of y and z in equation number 1 and then we will be getting the value of x. Now here we have got the value of x, y and z as 2, 2 and 2. And now I hope you have understood this one. In the next class we will be having another type of the sum, that is where the rank of A and augmented matrix will be same, but that rank will not be equal to the number of variables. That will be the case of infinite solution that we will be doing in the next class.